All right, you're being recorded. Let's do a couple things from last week. Um, in particular, just a little primer on making sure that you have output syntax in your output. I don't think that should be a problem. There's a journal file that you should at least be aware that exists because it can be a lifesaver in some cases. And then we started on this recoding thing last week. I don't think I was able to finish it, and we can sort of work through that. We can work through that as well. And so for the homework assignments, as I have or as I mentioned, um, you will need to make sure that you have the syntax turned on. So you get, like, this is just that get command is just a command that when I open up a file, it produces that get command, and it tells me that I opened up that file. And it gives me a little bit of additional information. And as I do additional work, so for example, if I do transform, recode into different variable, and I take our favorite color variable, and I say one, or I say we want to call this red, and I say if the old value is 1, I want to make the new value 1. And then I want to say if it's a system missing, or if it's system or user missing, I want to make it system missing. All other values, I just want to make 0. So we did this a little bit. We walked through this briefly last week, and it's just sort of, hopefully it makes sense. So I have this categorical data here that is not going to let me pull it up right now, but I have this variable that's called favorite color, and the favorite color variable is if it's 1, their favorite color is red, and I just want to make that, I want to dummy code that into a new variable. So I have a new variable that's called red. Everybody that's red in the old variable is going to be 1. If they're not red, they're going to be a 0. And this will be something that you'll have to do a fair amount for the different data projects that we work on. And so this little bit of input that I gave it here, I said if it's 1, make it 1. If it's missing, system missing or user missing. Can anybody define the difference? System missing, user missing. What would the difference there be? Anybody want to take a shot at that?
One, if I am missing the data because the participant did not answer, and the other one if I did not input it into the system.
But SPSS wouldn't know that distinction unless you told SPSS. So the difference would be if there's just a period where the data should be, that's referred to as system missing data. We can also use a number to indicate that it's missing. So sometimes people will use -999 as an indicator that it's missing. And then that would be considered user-defined missing data. And you have to go into SPSS and tell SPSS for the data set that you're working with that -999 is missing data. And there's some advantages. There's some advantages to doing that as opposed to just letting, just using system-defined data. But they're not particularly salient for the work that we'll be doing in this class. But in some cases, they will be. And so I said, if it's system-defined missing or user-defined missing, just make it system-defined missing. And then everything else, just make it 0. And I'm going to say OK, and I'm going to say OK. And this is what I want to show you. This is a little bit of syntax that comes up. And this is when, so let's say there was some homework problem where I asked you to do some work and you needed to dummy code some variables. This is what I'm going to look for. I'm going to look for something that looks like this. And I can read that easily enough to see, did you do that in a way that makes sense? Maybe not exactly the same way that I would do it, but in a way that makes sense for the data that you're working with. And so this output is actually more important than, in some cases we could also do, I could do data, I could do descriptive statistics frequencies, and I could do my favorite color variable. And so here we see the syntax that it said frequencies, and then it gave me the variable equals favorite color, and then this is another argument that you can add to that, or that, and in this case, SPSS added that to it, and then this is the output from that. And to be honest, from my perspective, seeing this is more important than seeing the actual output. So as you start each one of your homework problems, please, please, please make sure that you see this code as you execute commands within SPSS. And in the later versions of SPSS, so anything probably after 19, by default you get this. In the earlier versions of SPSS, it's a preference that you have to set. And so in some cases that preference might get turned off. And so if I just show you, under this little checkbox down here, display commands in log. If that's unchecked, you won't get any of that on syntax. With that display commands in log checked, you'll get that syntax. So by default, this is checked, but if for some reason it gets turned off and you're not getting syntax, that's the place where you go to make sure it gets turned back on. Make sense? And so in the homeworks that you do, it's just really, really important that we make sure that we have that you're getting the syntax. And I've had some students in the past, and I feel really bad when I have to do this, but they've done the whole homework, and they send me an email and say, "Dang, the syntax wasn't turned on," and I say, "Dang." I look forward to seeing the syntax. And so that's just, I'm sorry, that's just the way that it's just the way that I know what you did. If I don't see that, I have some ideas of what you did, but it's really important. So I can't emphasize that enough. And although I think I probably am approaching a point where you don't need to hear it anymore. The other thing that this is sort of the lifesaver, if you go into preferences and under the preference called file locations, you'll see this thing that's called session journal. And in my case, this gives me the path to where it's at. And Windows puts it in they used to put it in a temporary file or folder. I don't know if they still do or not. I would strongly encourage you to move that someplace where it doesn't get deleted. And you can move that by just changing this path. And so I'll leave that up to you to figure out how to change that path if you have a Windows machine. But then there's a file in this folder for me that's called statistics.jnl, and it's a log file of everything that you did, but it's a log file of all of the syntax. So it shows a date, and it shows everything you did on that date. And it stores it, if you tell it to append, which is the default, instead of overwrite every time you restart a new session of SPSS, it will start with a blank file. Don't do that. Just leave it like this. And it will I can go back and find something when I used to use SPSS a lot, and I would send a manuscript out for review, and then the editors would have some comments, I could go back and look in this file for work that I did 6 months or 8 months or even a year ago to understand, well, now what did I do? Because my notes weren't always as careful as they should be. So this can be a lifesaver, and this would actually save your life if you were in the situation where you didn't have the syntax turned on, and you sent me an email and said, oh, sorry, the syntax wasn't turned on, and I sent you an email back and I said, sorry. You could go back and just run all of this syntax, and you'd be done, essentially. So just so we have this in case it is something that will. I think it's something that will be, if not for this class, it probably will be useful. So where did it say put that? Put it here, and here maybe, and here, and here, and here, and here, and here. So this is just, you can just open this up with the text editor. And so this is just telling me all the stuff that I did. But let's say I just wanted to run that frequency table that we just did. I could just copy this a little bit. So I just copied, those of you that are back bumping, I just highlighted these couple rows of syntax here, and I copied that to the clipboard. And then I can do file new syntax, and I can paste that into the syntax editor. And I always forget with SPSS if I need to highlight the rows that I want it to run, but just press the big run button, and it will re-execute those rows. So now I have this twice. The second time, just run. So being able to do things with syntax. Again, maybe not so much for this class, but if you continue to do statistics in your academic career, you can do things a lot faster, believe it or not, with syntax than you can with the graphic user interface. And with some things, not everything, but some things, like let's say I have to do something, I have to recode a variable that's got 25 different favorite colors, right? So I'm doing favorite colors, but instead of just red, green, blue, there's 25 different favorite colors. That would require me to go in and run that command 25 different times because you can only do one color at a time. You could easily do the syntax and just do copy and paste, and you could do it in, I bet I could do it in half the time or maybe 25% of the time. So even though syntax for some people who don't write code or they don't have experience with writing code can be kind of scary, I think, at least it was for me. It can be your best friend, and it can save you a lot of time. So just something to remember. Other questions? Everybody got a copy of SPSS? Or you have your eye on where you're going to get a copy of SPSS? Good. If not, you'll need it next week for sure. So make sure that you're.
Do we need it to have it during class?
No, you don't. You don't necessarily need to have it. In some cases, it might be useful, like if we're working through.
Now my laptop has no storage for it. But
Yeah, you'd be just fine not having it, and in some cases, there might be a slight advantage for having it because you could work through your data while I'm working through some other data. But in some cases, that doesn't work for students either because it can be somewhat distracting for them. I think that covers everything that I wanted to cover about SPSS at this point. Unless you have other questions, we'll move on. And I think we'll move on with I think we'll move on with just a quick review of a couple of the concepts from last week. So what are the levels of measurement? Everybody's got that down, right? Um, um, which levels of measurement assume equal intervals? Or which level of measurement? Is that it? Interval n ratio, right? Interval n ratio assume equal intervals. How about an example of interval level measure that isn't temperature? Can somebody think of an example of a interval level measure that's not temperature?
Most Likert type scales would make the argument that they are.
Yeah. I think that we talked about. So that's a good answer, and it's always one I struggle with because some students, and I had a gentleman in my class this summer, undergraduate stats class, where we talked about levels of measurement, and he was ready to fight me before he was going to buy into the fact that temperature was that 0 was an arbitrary point. That 0 doesn't mean absence of temperature. That temperature is not ratio, it's interval. And he wanted other examples, and I just sort of scratched my head and made a similar comment that, well, we treat some measures as interval. But I know there's other things that we would consider interval besides Likert or semantic differential scales, besides temperature, where the 0 would be arbitrary. But for the life of me, I always struggle with identifying those. So how about one of the other things that we talked about just briefly, the difference between an independent and dependent variable, and being able to read a research paper and identify, well, what's independent and what's dependent in this particular study. And so if we were going to design an experimental study that had, if we were going to design an experimental study, what the manipulation, is that going to be our independent or dependent variable? The things that we manipulate. Everybody understand that? And if that doesn't sort of, that's such an easy question. If that isn't clear to you, we should talk, and I can try to help you work through that or get you some material, because that's pretty clear, or that should be pretty clear, because we really won't have the luxury of sort of taking the time to sort of talk through all of that. It's going to be, it'll have to, I think it'll flow a little quicker in here than that. And so if you need to brush up on those concepts, I would encourage you to find, there's a lot of good internet sources, even though you maybe tell your undergraduates, be careful on the internet when it comes to sources, but there are some good sources on the internet that can help you work through these. And there's a lot of, there's probably 100 textbooks over in the library, research methods textbooks, not all COM, but different research methods textbooks that they keep, that there would be a section or maybe even a chapter devoted to this. So, Anything else from week 1? Anything else that, okay. Then let me get this going. And the one thing I can't figure out is that power strip working or not? It seems to, right? That means I'm, does that mean it's charging? And that means it's not charging, right? That means it's not charging. That means it's charging. Thank you. I'm just not so fast in those ways. So let me start this. And so the other thing that we're going to just spend a little bit of time, you don't have to do this if you don't want to. What did I give for the deadline for talking to me about your data? Is that this week? Is that Monday? So by next Monday, and I've met with a fair number of people over the last couple of days, and last week. And so we won't have another class period before I've asked you to have that done. But does anybody have data that they are planning to use that you haven't talked to me about yet that you want to talk about now? So just tell me a little bit about, what's your first name?
William.
William, tell me about the data set.
It's collected while I was at TCU. 216 respondents from all over the globe. They were either members of the debate team or not members of the debate team. And so
how did you collect it?
Debate. So I was part of TCU's Glow Initiative, where you go, you get selected to go travel to all these different Oxford and all these different universities in different countries and see how the education is taught.
Yeah.
During summer. So I just did a month of that, traveling and visiting. And every time I would go, I'd meet the people in the International Studies office and get their card. And then when I got my survey ready, I just emailed to them and had them distribute it to their international students. And so that's why I was able to get those responses.
Yeah, so it was international debate students or just international students?
International students, but debate's bigger. Well, it's pretty big everywhere, I think, but now it's growing. But some of them were debate students because we wanted both. That's what we were comparing, was debate versus non-debaters.
And so what were the dependent variables?
So dependent variables, I have it's a communication apprehension scale, which has four,
Dimensions?
4 dimensions, yes, sir.
Each dimension measured by how many items?
6.
6 or so? Yeah, good.
So, and a couple of them reverse coded, but 6.
Yeah,
I
perfect.
have informational literacy, which is measured by 17
Yeah.
items. Argumentativeness, which is 2 dimensions, and each dimension is measured by 10 items. And then self-reported communication competence, which is measured by 12 items.
Lots of dependent variable, lots of multi-item scales, which were the multi-item scales were one of the things that you'll have to do factor analysis. And then independent variables? Some of those probably could be independent variables, but...
Yes, sir. So sex, age, years of education, whether or not, or how many writing classes you've taken, how many speech classes you've taken, whether you're a debate team, whether you ever did competitive writing, and then what type of school you went to, so public, private, or homeschool, or whatever, and then where your school geographic region was. So, but we ended up collapsing the countries to Europe, Asia, and America.
Okay, good. So you've done some analysis, it sounds like, with this data?
Yes, sir, I've done some, but I want to rework it for another way to look at it.
Yeah, and just because you've worked with this data, your data before, my guess is you will not have done exactly the same things that we've talked about here. You maybe will have done some of them, but you will not have done them the exact way that will probably work them here. So that is not a prerequisite to have data that you've never worked with before. It sounds great, William. If you want to meet and talk about it, we can meet to talk about it, but I don't need to because that's good.
The only thing I was concerned with was cutting everything down to 10 to 15 variables, so I didn't know if there's just some stuff I can just, how far.
Yeah, so, and that really, the sort of the driving, or the sort of motivation behind that is like for one of the, maybe that's the second homework assignment that we do, where I have you really start thinking about your data and what missing data do you have and what problems might that missing data be causing, and in some cases, if students have 80 columns of data, it's just almost overwhelming for them to start thinking through, well, where do I start? Well, you start at column 1, I guess, and then you work all the way to 80. But that's just way more work than you need to do for this class. And so, really, what I'm asking you to do is to take a subset of those variables, and in a way that logically makes sense. And the reason I'm asking you to do that is because it will help. It will help to. Just sort of clarify your work, and it just has to be some reasonably logic. Just pick 2 of the dependent variables that make sense, and 2 or 3 of the independent variables that make sense, and just work with that set of variables, and you'll be good. Good. Who else has data? And what's your first name again?
Tyler?
Tyler?
Tyler.
Thanks, Tyler.
So this is a data file that I collected last semester. Came up with null results. And so it has 230 participants in it. It has 2 independent measures. One is, so they take a little logic exam, and they either do well or poorly, so that's one independent, and then the feedback is either fixed or growth mindset feedback.
And do you manipulate whether they do well or poorly?
Yeah, so it's a 2 by 2. So either they, in one condition, they do really poorly, and then we tell them they do poorly. Others, if they do poorly, we tell them they do, wasn't so bad. But when they get told they're junk. And then for dependent measures, we have a manipulation check, which was growth mindset, and that was 10 questions. A cultural worldview, which was 13 measures. Policy questions, these are taking on like MSNBC policy survey, and moral foundation questions as well.
I don't. Help me understand, Tyler, the connection between the manipulation and the dependent variables. So, like go ahead.
So the original goal was to see people who had a growth mindset or a fixed mindset. How does an induction of a fixed growth mindset change their moral foundations or their attitudes toward policy, social policy issues such as immigration and stuff.
Yeah. And there didn't seem to be. Did the manipulation check sort of work?
Only for our negative. So apparently, when you tell people that they do poorly on a thing, but they have room to improve, so you give bad feedback, but it's growth feedback. That works. They're really motivated at that point.
And then the one that doesn't work would be when you tell
all the other 3 conditions. So even if they do well, and you say, "Oh yeah, you have growth mindset, you have room to improve."
Yeah. And so the one thing that you'll have to do, for example, when we do regression, you'll have to dummy code. Well, there are 2 dichotomies, the 2 independent variables. Yeah, so you have 4 conditions total. Yeah, and so you wouldn't have to dummy code those, but we would have to create an interaction term, and that's easy enough to do. And then it might be where you could use some of the other variables that you might have thought originally should be dependent variables. They might be able to work as control variables. So maybe you want to control for some other trait that or state that the individuals might possess, and so they could be an additional independent variable in the analysis. And so that's the only thing that when we do the regression, I think I ask you to do 4 or 5 independent variables, but you'll be able to get there by maybe using some of the dependent variables as independent variables. And the idea there would be you're going to control for some of these other measures. Might not be at all what you'd do if you were going to analyze this for publication, because theoretically it might not make any sense at all. But it for our purposes, we can just sort of suspend that thinking and just do what we can to get your data to a place where it will work for the assignments that I give. So, make sense? Good, good. Thanks, Tyler. Who else has data that? Yeah.
Nathan, I've got 313 responses to a data set I collected about 2 years ago. I've already written it up and presented it at NCA, but I've never done like Uncovas or Moncovas with it, which is something I'd like to do. So there's still stuff to be done with it. Multiple IVs, pre-attitude, demographic information, that kind of stuff.
Survey or experimental?
Experimental. There's 4 different divisions to it. We got we messed around with the message and the source. They got 1 of 2 messages and it came from 1 of 2 sources.
And the manipulation was what?
They either got we took Ken Ham and Bill Nye's debate on evolution versus creationism. They either got Ken Ham's opening statement or Bill Nye's opening statement, and then they either got a generic science source or a generic religion source. So we pulled across those.
Yeah, yeah. Good, good. And theoretically, any particular theory that you guys were
working
working?
on language expectancy theory.
Okay.
How people respond to those things, like variables in terms of DVs, output variables like source derivation, message derivation,
Yeah.
Persuasion, post-attitude, that kind of thing.
Cool.
And they're all multi.
Good. They're all multi-item?
Yeah.
Yeah. And the N you said again was 3?
13. I
Oh.
think when we cleaned it, it was still about 200.
Yeah, you're good. Good. Yeah, sounds good.
Okay, cool.
Anybody else? Lauren? Thanks, Lauren.
So I'm using data from another class I'm doing in the sociology department, and it's research data from the ICPSR, and it's survey.
It's what? I missed the first part. What data?
It's data from like the big ICPSR.
And what's that acronym stand for?
I've got no clue. It's a huge data set. Like it's a huge website that has like a lot of data sets.
The International Consortium for Social Research and Practices, I believe. Something like that.
Okay. Okay. So they collect a lot of data and they make it available for the public to.
Yeah, and
Good.
pretty much any site.
Good. Good.
So I'm doing a survey of inmates in state and federal correctional facilities.
Wow.
Like another class, I'm doing the correlation between family physical and sexual abuse versus criminality versus the stranger physical and sexual abuse and criminality to see if there's like a difference between like criminal history.
Yeah. Yeah. And so the set of data that you're working with here, Lauren, is what would the independent variables be that you'd be looking at?
I've got age, race, if they've been physically or sexually abused by parents or by strangers. I have things like pretty much it, and education also.
And so these are all people who are incarcerated?
Yes.
When was the data collected?
2004.
Wow.
And there's 3,686 responses.
And then the dependent variables would be?
So I've got, if the perpetrator is a family member, their criminal.
Is that just a dichotomy? That if the perpetrator was a family member is just a nominal yes or no? Probably won't work for a dependent variable for this class because it has to be we don't do anything that in this class that would use a dichotomy as an outcome. But it could be an independent variable for sure. What other dependent variables might you have, Lauren?
Their criminal history,
So the criminal history would be what?
So like if they're first time offenders, recidivists, current or past violent offenders, recidivists that have no current or prior violent offenses and drug offenses instead.
And would you be able to put that on some kind of scale?
I can probably try.
It sounds to me like it might be ordinal, but I'm not even sure that it's ordinal.
No, it'd be more nominal.
Yeah, and so then it would be, is there some way that you can take that nominal measure but it's got to be something more, it's got to be something that would be continuous.
Maybe try to find the number of offenses they've done. That's probably
Yeah, that would be good, or if there'd be some other way that you could, Lauren, if there'd be some other way that you could sort of recode that into a sort of a logical, and it doesn't have to be ratio, but it has to be something other than nominal or a dichotomy. Good, good. What other dependent variable might you have?
if they've been fights after using drugs or alcohol.
If they've been what?
If they've been in fights after using drugs or
Wow.
alcohol.
And do they ask how many fights or just a dichotomy?
It's just
Yeah.
Yeah, most of these are honestly just dichotomies.
And so there might be a way that you could take several dichotomies that sort of relate to, I don't know what the sort of the theme that would be across those, but there might be, um, I, and if I, but there might be some theme that would run across several dichotomies that you could then just sum up those dichotomies, and a person that had a higher sum would have more of whatever that theme is as opposed to somebody that has a, so it could be, I don't know if level of violence or something like that would work, but you'll definitely want to think about that, because it doesn't sound like any of your variables, Lauren, are dependent variables sort of right out of the box that we would be able to use. You'll have to, there might be some in the data set you just have to find, because I assume there's
Yeah.
thousands of columns of data, or at least hundreds of columns of data that they have a good code book.
Yeah.
So there's a good code book that clearly delineates what each of those columns represent. Yeah, and so if you have that, and if you're armed with that and a little bit of motivation, you'd be able to go through and probably pretty easily find some dependent variables. So I think what would be useful in your case is if you could, in the next couple days, look through that data and come up with, here are several dependent variables that I'll be able to, either that you find in the data set or that you'll be able to construct, and we should talk about that, and then I think you'll be good to go. And I'm very confident that you'll be able to find that. It's just a matter of, I think it'd be better to find that now than to wait until later in the semester. Fair enough? Good, good. Other,
My data from
what's your first name?
my first name is Sujan.
Okay.
My data came from Korean college students in South Korea, and my data has two dependent variables. One is that Korean students' attitude toward older adults, and another data is that their attitude toward their own aging. And then independent, I have three independent variables. The first independent variable is their negative communication with their grandparents.
Mm-hmm.
And then another independent variable is their positive communication with their grandparents. And the third variable is their contact frequency with their grandparents.
Mm-hmm.
And then mediator is interval anxiety. Anxiety when they feel, anxiety when they feel when they communicate with their grandparents. And then moderator is age status. So how much they are aware of age of their grandparents when they communicate.
Mm-hmm. Mm-hmm. And where was the data collected? Or how was it collected?
How was it collected? It was collected college students in Seoul University.
Okay, okay. And how large was the sample, did you say, and I missed it?
300.
Okay, okay. Um, yeah, everything sounds fine to me. I don't think you'll have any problems. So I think you're good. If you want to meet, I'm happy to meet. But if you're comfortable with um, with moving forward, you're good. Other. So I look forward to talking to, if there's nobody else, I look forward, those of you that I haven't talked to, I look forward to meeting with you on or before next Monday. We could potentially meet Monday and get things worked out easily enough. All right? Anything else? Questions about data? Anybody have no idea what they're going to do for data? That wants to self-disclose that? Because there's there's a lot of public data available. You could talk to Michael Kramer or Eric Kramer or John Bannon. There'd be a lot of data that you could find. The one thing that I was going to mention about data, I know that there's several people in here who have the same advisor and maybe using the same data set, which is perfectly fine. But what we need to manage is, and I use the word manage in quotes, but what I think we need to avoid, or what we need to avoid, is two people doing exactly the same analysis with exactly the same set of variables. And I'm fairly familiar with this set of data, that at least one of the sets of data that was sent out, there's a lot of options in there. And just by chance, I think it's highly unlikely that two people would land on exactly the same set of variables, but it could happen. I don't want to make you I don't want to make you, I don't want to sort of overmanage this and have you somehow speak to your colleagues and make sure that you're all not doing the same thing. I know you guys probably talk some anyway, so to the extent that you talk outside of class, maybe you can work some of that out. And then what I would do is, if I grade a homework and I see that two students did exactly the same thing, I would, or use exactly the same variables, I would just, the first time, probably put a nice note that asks you to be more careful next time, and then you might have to be a little bit more diligent about finding out who else is using this data and what they're going to do. But it wouldn't hurt you in terms of a grade. I don't know, if I saw it a second time, would I throw a fit? Probably not. But at some point, I would. At some point, I don't know that I'd ever throw a fit, but at some point I would. I don't know what I'd do. Ask you more directly to make sure that this doesn't happen. But I think that should work. I'm not worried about it. Because again, the thing that we need to avoid is two people using exactly the same set of variables. And given how wide the data is, it doesn't seem particularly likely that that's going to happen. So, any questions from those of you that are in that? Which I don't think it's a third of the class that have the same advisor that they work with, and the same. I don't know. Was it just a set of data, or was it several sets of data? Yeah. Several. Yeah. So it's gonna be. I think it should be okay. So questions about data? None? Good. So for this week, I had a couple articles, PDFs that you found online, right? First chapter from the textbook, which the connection between the first chapter and Statistical Power was that one section called Statistical Power, and the rest of it was more just setup, that sort of typical setup that you would find in a advanced statistics textbook. And so a lot of that material, when you read the section on general linear models, my guess is those of you that got there and were able to make it through that section, you probably you might have benefited some from that discussion, but it's not one, nor are many of those topics ones that will play a large role in this class. But you take a class in psychology, in advanced statistics, they're going to talk a lot about the general linear model in all likelihood, and it's very foundational. So it's one of those things where you read it, hopefully it's in the back of your brain somewhere. When you get in another class, it might be a source that you could go to that might help you sort of think through a topic that they might be working with. So I would not be sort of just a cautionary, positive cautionary note, I think, is that if you read that first chapter and only picked out a couple things that were useful, you probably picked out a couple more things than I would have picked up if I were in your shoes. and so I think you'll be okay. So I wouldn't, don't get too nervous um, about where you're at and where that chapter's at in terms of understanding. If you understood it all and it all sort of fit into some larger schema that you have about statistics, great. That's going to serve you well. But again, if some of it was what the hell, that's okay as well. And we're gonna be able to manage through that over the next 15 weeks now. So fair enough. So I do want to spend some time talking about power, and particularly those two articles, and we're going to focus most on the Cohen article, and over the next over the rest of our time together, um, we'll talk about some things that, what are the things that determine how much power you have in your study, and then what are the types of power analysis that we could do? And there's several determinants of power, so it'll take us a little bit to walk through those things. And then there's some sort of side conversations, or we can sort of go down a rabbit hole a little bit and talk about some other topics as we start talking about those determinants. And we'll do some of that. But then eventually we want to get to the application. How do I actually determine the sample size that I need for a study, which is the most common use of power analysis? How large does my sample need to be? And then we're going to use both the Cohen article, because the Cohen article gives you a way to do that. You might not have been clear about how to do that from the Cohen article, but before we're done here today, it'll be clear how we can use the Cohen article to estimate what that number is, or at least to get a min and a max of where that number should be. And then we're going to use that program called G-Power, which actually uses all of the same logic that Jacob Cohen in all of the work that he did as a social psychologist and a mathematician and statistician, uses all of that same work and puts it into a fairly intuitive computer program where we can give it a couple inputs and it will tell us an exact sample size that we need. And we'll see that our work there will square nicely with the article. So if we determine in the article that we need 185 people, when we do the G-Power and we put in the same inputs, it's going to tell us we need 185 people. So that's sort of the goal, to get to that point before we're done today. But as I mentioned last week, the key will be ensuring our understanding, as opposed to I won't feel bad at all if I have to start again with power application next week and continue to work through that material, because we just run out of time today. And so even though I have somewhat of an agenda here, it's not one that I feel strongly that we need to get through each week, and that will almost always be the case. And then you'll find, to the extent that we're not able to stick to the agenda, and I sort of am good with that, these week numbers will start not to make sense, right? And so just because I say it's week 2 doesn't mean it's actually week 2. Well, in this case, it is week 2, but the one next week, well, I think it'll probably say week 3. But later on in the semester, it might say week 11, but it might actually be week 14. It's not the week number. It's really it's the deck number. And I probably could say something other than week to just avoid that confusion. But then I don't have a good answer as to why I didn't do that. I'm just going with week. So, but just a FYI as we continue to work through this semester. So the sun isn't doing us any favors there at some point, and I tried to work that blind to no avail. Did Shelley respond to our pleas for help? Do we need to text her and tell her to get somebody over here? No, I'm just kidding.
No response yet.
Uh-oh. So can everybody see that good enough, or at least to have it on your computer where we can sort of make sense of it? And I think when I looked at this morning, this was not there. It was whited out. So make sure you put a note up there that the columns are what's true in the population. because for mine, I don't know about yours, but for mine it was whited out. And I just had to highlight it and make the text black instead of it was white. And anybody know what we call a 2x2 table like this? There's a name for it. Anybody know what we call that? It's got kind of a funny name.
The Schacter two-factor, or that's a different thing.
I think that might be. We call it a confusion matrix. So so anytime we have sort of a 2x2 table, it's referred to as a confusion matrix, and it could be whether you're male or female, and whether you're U.S. or international student, and we could put that on a 2x2 table, and we refer to that as a confusion matrix. And I think in some cases justifiably so, because it can be confusing. In other cases, like the example that I just gave, maybe not so confusing, but it does take, if you're not used to looking at them, it does take a few minutes to sort of think through, well, what does this cell represent with these headings, and what does this cell represent? And regardless of what we use on for the rows and the columns. So in this particular case, we're looking at outcomes of statistical tests. And this is the outcome of our statistical test for the 2 rows. And it's what we conclude for the study. If you find other tables like this, oftentimes they'll talk in terms of the null hypothesis, which to me sort of adds another level of sort of thought and confusion to it almost, that's unnecessarily, that really doesn't seem to be needed. So I'm not talking about null hypotheses. I'm just saying, does our study find an effect? No or yes. And then what's true in the population? Or what's the reality? It would be another way to phrase that. And we don't know this, right? This is an unknown. We don't know what's true in the population. Or of course we wouldn't be doing the study, right? If we knew that truth, there'd be no need to do the study. And I can think of very few things where we know that truth. It's maybe that God or gods might have that truth, but it's not us. And so you have to enter this with that understanding that we don't know whether there's no effect or an effect. But we can dichotomize that and say it's one of the two, which is what we're doing here. And so if our study concludes that there's no effect, and in fact there's no effect, that's a correct conclusion, right? We probably aren't very happy with our null result because there's a bias against publishing null results, but that could well be the case where there's no effect. Your study concludes there's no effect, and in fact, in reality, there is no effect. That's study well done, right? Would be one way, because it's the correct conclusion. We never know that with a certainty, right? It's because we never know this, right? We only know this. We don't know this. But if in fact there's no effect, and you conclude there's no effect, correct conclusion, job well done. And the probability of that is 1 minus alpha. And what do we normally set alpha at? 0.05, yeah. And so it would be 1 minus whatever you set alpha at. You might set it at a lower value, or you might feel the liberty to set it at a higher value. But it's 1 minus alpha would be the probability that we make this correct conclusion. And then the other correct conclusion would be, of course, you say there is an effect, you find significant results in your study, and in fact, reality is that there are meaningful effects. That's another correct conclusion, right? Again, job well done, pat on the back to you. The probability that happens is 1 minus beta. We usually set beta at 0.2. So 1 minus beta is 0.8. And this is statistical power. And so this square, that lower right hand section would be, that's statistical power. 1 minus beta would be statistical power. So those are the two correct conclusions. And then, of course, you've been exposed to, I assume, over the years, the type 1 and the type 2 errors, right? And the type 1 error is where you say there's an effect, and there isn't one, right? It's the only error you can make when you say there's an effect. When you have significant results, you can only make one error. It's type 1 error. When you have non-significant results, there's only one error you can make. It's type 2 error, and that's what we make here, where you conclude there's nothing meaningful going on with the variables that you're working with. There's no meaningful relationship going on with the variables that you're working with. That's your conclusion, but there really is. And you've missed that for whatever reason. Does that make sense? Type 1 and type 2 errors should be repetitious, maybe an undergraduate class. Maybe you guys talked about it in 5003. What error is worse? What error if we had to make an error, what error would we want to make? Type 1 or type 2, and why? So take a minute to talk to your neighbor, decide what error is worse. And so one way to think about this is, and this is the extreme, maybe not the extreme, but certainly a way that will resonate. If we make a type 1 error, we have a drug for cancer. That's our area of research. I have a drug for cancer that I say cures cancer. They're dead in 8 months, right? It doesn't, right? So that would be a type 1 error, right? Where I say my drug will cure cancer, but it doesn't, right? It's a type 1 error. And or the other would be, I say my drug doesn't cure cancer, and if I would have given it to them, they would have lived, right? So that's the type 2 error. Which of those do we want to avoid? So just take 5 minutes, make an argument for which of those two you want to avoid, and then we'll talk about your insights.
It's going to be wrong.
I don't know. When I talk about this now, we just finished talking, but I may be way off base what I wanted to talk about, but I see there's this paper. I'm a big baseball guy, and I found this thing that you had wins as a dependent variable and all these, basically independent variables, but you wanted
But this is just a dichotomy, right?
Yeah.
It'd be, or is it wins? I guess it'd be wins for the season, right?
Right. But you could come up with other dependent variables and play other of these independent variables against those. And there's a lot of great databases,
Sure.
different seasons and stuff.
Sure.
I can get access to. So. I mean, but I don't. If
It's
you
not-
think that's too corny,
Well,
it's
not corny. I think it'd be a lot of fun, but as a communication class, unless you can convince me that that's communication, and I'm not
Yeah,
close
sure.
to the idea, I would rather have you work with, or I need
Okay.
to have you work with data that's
Well,
communication. And so I'm open to an argument as to why that's communication.
Sure.
And-
No. It's. I mean.
It might be. I don't know. It might
Well, other than that, I work in work with sports kids and stuff. But I was also looking at some Pew Center journalism and media data sets. So I'll try to work up one of those.
Or just be sure that that's not communication, because I don't know, to be honest. But I'd be open to an argument that you could make.
Oh well.
On its face, it doesn't seem like it is, but I just might not understand it. You might be able to say, well, if as a baseball, as a manager or as an executive, if we understood these things, we could communicate in a way that I don't know. It might be a stretch, but it might be worth it too.
Yeah, well, no, I mean, if I had more data about some specific thing like salaries or media or something like
Good.
that, but I'll find something.
I look forward to talking. So wrap up in just a minute or so. 30 seconds. So what's worse, type 1? How many people think type 1? How many people think type 2? So a nice mix. Let's give seem like the minority. Let's give the minority the type 2 group. Let them argue first.
So I've always heard, this is what we're talking about, type 1's worse, type 2 is better. But in this case, the context of cancer,
Okay.
right? If I say something works and ends up not working, that's already implied that replication is going to occur, so we're going to give this pill to patients. If it doesn't work, it's going to weed itself out. Okay, people are still going to die. If I reject something and then publish it and say this doesn't work, and nobody's looking at that, then the cure is going to die. So in that case, type 2 is worse. So I think it depends on the context.
Good. So
people always say type
it's more nuanced. Then how about for your typical communication?
Type 1.
Why? Why?
Because no one's dying. And we're not implying replication.
And okay.
But what I say,
Wait.
and my partner disagrees with me strongly, but what I
She
say
disagrees or agrees?
Yeah, disagrees.
Disagrees. Okay, good.
I say that type 1 is a better error for the community, and type 2 is a better error for the researcher. But type 2 is a worse error for the researcher, and type 1 is a worse error for the researcher to make, and type 2 is a better error for the researcher to make. And what I mean by that is, if if you publish something that has a type 1 error, and then it's found out, then you're a fraud or that you messed up or whatever, then you get all this ridicule, it's bad for your reputation. But if you don't publish something that could have helped like a lot of people, then that's like worse for the community. So from a communication perspective, I was saying if you like, let's say you're doing, the more you talk to your children, the less crimes they commit, and you find that there's no effect when there actually is one. Well, if you'd found that effect and published it, you could help the community. But if you say there is an effect and there isn't one, it doesn't really hurt anybody except for you yourself when somebody replicates your study. And like Nate was saying, your study gets replicated, whereas if you say there's no effect, then your study's not going to get replicated.
Yeah, good. I think all good points. What other arguments? So everybody else. So was it just who else said type 2? Would be the just. So type 1. Why type 1?
Oh no, I'm not. Wait, speak up.
I feel like type 1 error is the more
Egregious.
outrageous or shadier error because it's detecting a shady or some word.
But it might not be shady at all, right? It could be, everything's up above. We're not cooking the books.
But the reality is that we actually never know, like you said, what's true in the population is something we don't know.
True.
So I don't want to detect something because, people could take that it could get established as a standard, it could get established as that which people do, when in reality there is no. And so I would rather err on that side. I would be hesitant to err on that side than, figure out that I didn't get an effect when in reality there's something. Someone down the road will figure it out. And if that effect is strong enough, it will show up in other places. It's not my way of studying, it is not the only way. So I absolutely want to prefer and be in the zone of committing a type 2 error rather than
I think I'd rather not detect something than detect something that's not there.
You'd rather what?
Not detect something than detect something that's not there.
So you would rather make a type 2 error? Certainly better for tenure, right? If by that sort of snarky, uber snarky, the idea that we don't publish null results, right? Generally, there's bias towards publishing null results, and if you're not finding any effects, good chance you're not going to get those published anyway. So, other thinking on how we might examine or think about. Tyler?
I agree with Vitra. I would rather miss a detail than present a false fact accidentally. I think you can kind of hear this in the law. Like, law provides it's better to set a man, like guilty man free than convicted innocent one.
I've never thought about that before, but it might be logic that could be brought to bear on this and help us think through.
I have one other point for type 1, which is sort of also going on that statement, is there are so many ways to stretch and get an effect. I could increase my sample size. I mean, the things I could do to get it. And I'm just going back to, I think the exercise was done last year where they took 100 or 200 of the topmost JP articles and they couldn't replicate it. And this was like, maybe the researchers are gone, but I was like, that's devastation to their legacy. And so maybe if I could just respectfully say that they did all kinds of those things, increase sample size and, fool the statistic, but today the truth's coming out. And so I'm thinking that's a shoe that most of us
Yeah.
Again, I think context really matters. Like, hey, Grandma, we tried this medicine on you. Turns out it didn't work. That kind of sucks. Versus, oh shit, we had the medicine. Grandma already died. I mean, the context matters.
Yeah, it does, and I think that's sort of the extreme. I think Kant's
Dying is involved.
right, as opposed to, did you really understand the relationship between anxiety and public speaking, which of course is really, really important, right? But it doesn't rise to the level of like that. But in terms, I think it's useful to understand in practice how we how we think about these errors. And so what do we normally set alpha at? What's typical? 0.05. What's beta normally set at? So we set alpha 4 times lower, right? 0.05 is 4 times lower than 0.2. So we are protecting against type 1 error at 4 times the rate as we're protecting against type 2 error. Why can't we just sort of maximize our ability to, or minimize the likelihood that we'll make a type 1 or type 2 error? Can't we just minimize both of those? Wouldn't that be the ideal? Make this 0.001, make this 0.001. Why don't we do that? If this is really that important, why don't we do that?
Too many participants.
To what?
You need too many participants.
It would be a waste of a lot of resources and participants and time and what's that? Right, I think you of course make it very difficult to actually find effects, and it's just it's a cost benefit analysis that one would have to do, and that cost benefit analysis would hold for a communication study that you would do, or would hold for of course not the same cost benefit analysis, but an analysis could potentially hold for medical science and what they would do, where what is the cost of moving alpha from 0.05 to 0.01, or what is the cost of moving beta? What would that cost us in real dollars, and what would we get from that? And as you'll see as we continue the discussion, and as you probably know from your practice, there are no free lunches in science, right? There's a price to be paid for everything that you decide you're going to do. So, of course, if you decide you're going to protect against making type 1 error, well, the price that you pay there is you're going to, all things being equal, you're more likely to make a type 2 error, and vice versa. So, I think it's instructive and a good place to start when we talk about statistical power, because with statistical power, we're really talking about understanding. We're really talking about understanding the likelihood that we're going to find an effect when there really is an effect to be found. And so, turning to the next slide. Just a few definitions that I've pulled together from different sources, and not all of them we could go through and we'd come up with the same. We'd come up with the same conclusion. Yeah, that is because they all are definitionally definitions of. They're all definitions of power that would get us to the same place. But I think the reason why I provide so many different definitions is what's key for you to do is to find one definition that works for you. And you might have a different one than any of these up here, one that you ran across earlier in your academic career, and that's the definition that works for you. But what you need to do, I think, is to find a definition that you can sort of commit to memory and that you'd be able to work with as you think about statistical power and as you think about doing social science. And the one that I found early on was the very bottom one. And it's just because it seems very simple. It's the probability of not making a type 2 error, and that's what statistical power is. And so I would encourage you to think about these or other definitions that you'll find in other sources, and find one that works for you, and then sort of commit to that. And because it is one that, as you talk about data, as you talk about doing research, as you talk about statistics, it will come up a lot, and it should come up a lot because it is that important. So Having said that, there's just three different determinants of power that I want to talk about over the next few minutes, and then we'll dive into just exactly how do we what are the different types of power analysis, and there's really only one of them that makes sense, and we'll talk about that one, and then we'll actually talk about how do we calculate the sample size that we need for a study that we're thinking about doing. And so that's about the extent of my Latin, cateris paribus, all things being equal. So all things being equal, making alpha less strict, for example, moving from 0.05 to 0.1 increases power. Hold everything else constant and just move alpha up higher will increase your power. But it also increases the likelihood that you'll make type 1 error, right? Again, that lunch isn't free, and you'll pay that price, and the higher likelihood of making a type 1 error. And if we sort of look at that graphically, which may or may not be all that helpful, but it's something that I sort of like to see represented. And I think I represent this for all of the determinants of power that we're going to talk about. So we're just doing a simple t-test, which this isn't all that important, but it gives you what's the test that we're doing, and that's the test that we're doing. We're testing the difference between two independent groups. Is their mean different or not? And we set these things constant, a sample size, the n of the two groups is equal, and an effect size. In this case, the effect size is, we'll talk a little bit about effect sizes here in a minute, but we're using it's not r or r squared, it's d is the effect size that we're using. And so this is not unimportant, but it's not the most important thing on this graphic. What's the most important thing in this graphic is here's our power, ranging from something that approximates 0 to something that approaches 0, instead of approximate, something that approaches 0 to something that approaches 1. It'll never be 1. It might round to 1 at 1,000 decimal places, but it'll never be 1. It's asymptotic, we would say, in that it just gets infinitely closer to 1, closer to 1, closer to 1 but it never is actually 1, just like it'll never be 0. And so here we start with alpha at 0.001 for this particular test, and we see our power is about 0.3. And then we move alpha to some number that's more typical, 0.5, and if we follow that up, our power increased a lot, right? It's not linear, it's log linear, or certainly it's not just a linear line. We increase really fast here, and then that increase, the return diminishes as we make alpha larger, right? And so out here we have alpha equal to 0.5, and we only move from 0.8 to something close to 0.9, and there's just not a lot of gain to be had there. And so this curve that we're seeing here is very typical, that some small changes early on on the x-axis will make a big difference, but then there's diminishing returns in terms of continuing to in this case increase alpha. So one way to increase your power, just change alpha. Is that something that we can easily do? You can, right? What's the downside? Besides making a type 1 error, what would be the other downside? Yeah, I mean, you can make the argument that you think alpha should be 0.25, and you can make that argument, and somebody might not read your manuscript, but it's unlikely that you're going to get that to slide through a couple of reviewers and an editor, And then if you do, and you get some jerk at a conference that says, hey, are you the guy that published the paper where you thought you could get away with alpha is equal to 0.25? And, just, it would be sort of it could, but I mean, it's just one of those things that even if you could get it through, I would want that to be a part of my reputation as a scientist that I think I'm good with the 25% chance of making a type 1 error. That just seems awfully inflated and at best and swappy probably at worst. So makes sense. So of course there would be the potential to make a change there, but we're really limited in terms of what we're able to do with alpha because there's a long. I mean, is 0.05 something that? Why is it 0.05? Why is that the number that we all gravitate towards?
Wasn't that Fisher decision to set that standard? But Cohen says, well, there's not really anything written in stone to be changed.
Yeah, it's not magical in any way. I had the same guy, the gum chewer guy that I told you about last week. That guy said that he had heard, and so this is getting dangerous, through about 5 or 6 generations of scientists here, that he had heard that or read that it just happened to be a nice, because he had this table that had all of these different probabilities and all of these F values, and it just happened to be that 0.05 was at the top of a page, and so it made a nice clean break for him in the way that he worked. And so 0.5 would be a good way to go, as opposed to 0.06 or 0.07 or 0.055, which would be as reasonable as 0.05. And so who knows exactly what that is, but it really has been a history of 100 years of us doing science, and it's just sort of ingrained in our practice. And so 0.05 it is. It's not, I don't know, is it arbitrary? What do we call that? Is it arbitrary? It's somewhat arbitrary, isn't it?
What means?
Huh?
It means something.
Yeah, it seems like it's not a bad number, but it's not something that, it's not a number that comes from, it's a number that comes from, that just sounds good, right? 0.05 is.
I guess that's right. It's arbitrary, just like words are arbitrary. We give them meaning, so we give that meaning.
Sure. Yeah, in maybe a slightly different way. But it could have, and this will be the end. At least for me, it could have easily have been 0.1 or 0.025, right? But we just were at 0.05. There's nothing magical about it. It's just somewhat. It's just been where we're at in practice. So that's the first. That's the first determinant, and then the second determinant, which we're at 4:30, so good place to stop. Let's take a 15-minute break, and then we'll come back and we'll talk about effect size and move forward from there. Thank you. Yeah. Stop the recorder.
I couldn't get my thing up, but I did find it, so I didn't find out my data.
Let me stop the recorder, and then we're going to talk about the data.
Can you run my data by you?
I'm going to go talk to, is it Brittany?
Yes.
I'm going to go talk to Brittany, and then I'll talk to you. But I'm going to stop the recorder.